Hi there, this is Dr. Embody with Project 6, our last one. So the purpose of this project is to use a class that we have created. In fact, you've been using classes all along. String, for example, is a class. But those are the ones that are built into Python, and you actually have the capability of building your own classes. And so in this case, we have two classes trying to represent Western playing cards. And there's a class for the card, and then you have a deck of cards. So we have a deck that is made up of 52 of those cards. And the game that we're going to play is a variation of poker. And you know, each person has two cards, and then there's some other cards that are dealt. And this is actually the purpose of the game is a betting game, but that adds complexity that we're not going to do. But you should check it out and kind of see how it works. So this is simplified. There is no betting. There's no taking of extra cards. We just look at the cards that are there, and there are 7 possible cards, and we have to choose 5 out of those to make the best possible hand that we have. And there's 2 players. So in some sense, this is very simplified. We have to look at 7 cards, find the best 5, and then determine, find the best 5 out of each player's hand, and then from that, determine who the winner is. And so there's a series of hands, like, there's one pair in there, or there's high card, or there's a flush where they're all the same suit, and so on. So that's what our job is. We deal out, and we have to deal in a certain order so that you're consistent in terms of mirror testing. And then we deal cards to each player, and then we deal the common cards. And so with your 2 cards that are hidden, and then the 5 cards that are visible, out of those 7, each player makes the best possible hand out of it. And there's no choices here. There is only one best possible hand. The game itself, when you play as a betting, you see these cards show up one at a time, and that's a big part of the betting that we don't do. And what we have in here is actually, let's start taking a look at this. We give you a skeleton file and the cards. So, and what the skeleton file has is it has a series of functions. Like I called it flush 7, where there will be, you're going to look at 7 cards in a hand, each representing the hand, and we're trying to see if we can find 5 cards, make a list of those 5 cards that form a flush. And that means they all have the same suit. And so if what we will return is a list of the cards if you can find it. If you can't find it, you return false. And then again, as we've done before, excuse me, to make this a functions that will actually not generate an error, we have the pass in there that you have to replace. So we take advantage of the fact that if a list has anything in it, then it will be true and it will be false otherwise. So in many respects, we're thinking of this as a Boolean that will return a list with something in it, or it will return false. And if it can find a flush of 5 cards out of the 7, it will return that list. And then we go down, and there's one of these for each of the categories. Is there a straight that is 5 cards in a sequence out of those 7? If so, return that. False otherwise. And along the way, we can you may make some simplifying assumptions. So for example, here's one where we're looking for 3 of a kind. You can assume that there aren't 4. Well, this is a simplifying assumption here. Notice I say you may assume, you don't have to do that. And then that means that you're going to check for 4 of a kind before you check for 3 of a kind. And so you can assume this this assumption to make your job easier, but you have to take care of that elsewhere in the project. So there's one of these for every one of the categories. And then we have a main, and there's some output there for you. Now there are 3 different things. So this, you can see here that these have there's actually an error here, so you have to create those at some point. But there's a list of the cards that are common, and then there's lists that are for each hand. So let's take a look at how the game plays as we've defined it. All right, so I'm going to show this in the shell, and so notice what we have. We announced that we're going to play poker. There's a set of community cards, and then each player has 2 cards. And so if I look at player 1, I take a look at these 2 cards plus these 5 cards, and I try to make the best hand that I can out of that. And the best hand is I've got 2 4s, and I have there's already a pair of 6s in there, and so I've gone in, and so one of the things that you have to do is you have to identify which pair which pair of cards is actually, well, in this case it ends up being a tie, but the winning hand, and we need to we need to specify that. Okay, and now, do you want to play another hand? Yes or no? If I say yes, it just plays another hand, deals more cards, doesn't shuffle the deck again. And now we see here that there's a winner, player 1. So you see in this hand, he's got 1 king, and there's 3 more kings. And so, in fact, we're winning with 4 of a kind. So to test this, we actually create special card files with the hands. We actually turn off shuffling, so that's why there's a lot of winning hands here. And you don't see that. We just have this particular test. And you just keep going. So here's another one. We have a tie with a flush, so they both are able to construct a flush out of this. For example, player 1 has 2 clubs, and then there are 4 clubs in there. Player 2 has 1 club, and then you can grab the 4 and make a hand, and we see we have a bug in my program. It's only supposed to return 5 cards, and I returned all 6. So obviously I got to go back and fix that bug. Okay. So there's how this goes, and let's in fact take a look at so an end will end this. Let's take a look at the flush. So how does this work? So I have a list of 5 cards coming in, and so we have the deck of cards. They get shuffled. I need to create the community cards. and I need to create the player's hand, and then I need to call that particular function, which is called flush 7. So what I'm going to do is I'm not going to actually play the game. I'm just going to create a hand. So how do I need I need some community cards, and I need so I need 5 community cards, and we all right. You don't have to worry about that. That's nothing you'll have to do. I was just in the wrong place. All right. So how might I do this? Well, I can say card 1 is a card, and I can just make up what we're after, a flush here. Whoops. We're out of the cards class. Okay, and I can print that card, and that's an ace of diamonds. Now there's 2 different ways the cards can be handled, and in fact I've got the wrong, so they can be handled with if you have a system that can't print symbols, such as on Mir, then we can use the version that has a D for diamonds, or we can use the other one. And let me grab that one. I happen to have that one, and let's see. So if I use that version, then you'll see that one prints with a D and the other one prints with a symbol. All right, so and again, that doesn't matter to you if you're using Spider. The symbol will print fine, but you'll notice in the testing on Mir that it will have a D instead of the diamond, because the Mir system can't handle the Unicode symbols. All right, so there we go. Now I'm where I want to be. Okay. I need to create a whole hand of cards, and I can either create, I can deal cards into my hand, as you saw in the lab, or I can name particular cards. And so what I'd like to do is have some particular cards. So that's how I can do it. So let's make my hands here. All right, so I've got 5 cards. Let's now make a list of them. All right, so there's a list of my community cards. Now let's make a player's hand. So I need 2 more cards for that. And let's have another diamond in there. Okay. And for right now, I'll comment that one out so that this thing will actually run. And how do I want to call my function? So we're going to have, I'll say L equals, and the name of my function is flush7. And it takes a hand. And what's my hand going to be? My hand is going to be my hand plus my community. And I'm going to comment this whole thing out here. Now let's see what happens. Let's print out what I have. So we're just going to call that one function, and my function returns none because it didn't do anything yet. So now let's put in a let's put something in there. Get rid of my pass. And how do I want to do this? Well, so I have 7 cards. What does it mean for them to be a flush? That means they all have the same suit. Now, how might I check to see if they all have the same suit? Well, there's a number of things, a number of ways that you could do this. There are 4 different suits, right? And they're and so I can check to see if cards are have the same suit, and you know, how might I do that? Well, I can make a collection of suits. So I could say something like, let's see here. We have diamonds. We have spades. We have hearts. And we have clubs. And what does it mean to be in a suit? Well, I can look back at my card class, and there is something that will return the suit of a card. So let's give that a try over here. Let's say C1.suit. What does it return? It returns the number 2. So the cards are, and that comes from here. When I created this card C1 over here, the suit was the suit was the second number. So these are done in the way of rank suit. All right. So when I say when I look at C1 and I say what is its suit, then it will return that number there. So we can take advantage of that and say, all right, so I have some cards in my hand. Then I can say if C.suit equals 1. And what is the, you might say, all right, well, which one is which one is diamonds, which one is clubs, and so on. Well, you can, what we could do is, instead of doing this, rather than looking it up, let's go, because we really don't care, suit 1, suit 2, suit 3, and suit 4. So if it's suit 1, then suit 1 dot append. Okay, and we can just go on down, or you could have just made a list of suits and done it that way. All right. So if it's suit 2, we append it on there. If it's suit 3, we append that on 3. If it's suit 4, we append it on 4. And now I have put each one in there. Now, how many of them can have, we're looking for 5 of the cards. So that means one of them, suppose one of them has a length of 5. And so if suit 1, length of suit 1, just a list, greater than or equal to 5, then I have a flush, all right? And I can return. But I only want to return the first 5. And again, I can do this. And so we have suit 1, suit 2, suit 3, suit 4. And what happens if none of those were true? And we return false. Okay. So let's review what we have here. We're trying to collect all 4 suits, and we check if the suit is 1, it goes into suit 1, and so on down. We do that with 2, 3, and 4. And now we check to see, do we have 5 cards in any of those? And so if the length is greater than or equal to 5, we take the first 5. Let's see how we're doing here. Oops. Append takes 1 argument. Oops, blew that. What did we want to do? We wanted to append my card. That was stupid. Let's try that again. All right, and so what happened? It returned the 5 diamonds. Well, that's good. So maybe my function is working. Now, of course, we can go back and can we improve on this? You should always go back and think about that. And I can take this and I can replace that with something and then I can say, we know there are 4 suits there, so I can replace all of this and say, all right, grab the suit and then say suits of suit -1. We have to count for the 0. Append the card on there. Now I could have, in fact, not. I could have used this as c.suit here if I wanted to. Is that more readable or not? You decide. All right, we append that on there. And now we still need to go through this. So okay, so we got all the errors out of there. Let's see if this runs. And I made those changes, and I see that I got the same result that I did before. And so is this more readable than what I had originally? Well, that's in the eye of the beholder. If I And if we think about it, there's likely there may very well be an easier way to simplify that. But in any case, you can see how I can write individual functions and then test them. And so Mirror is set up to test the functions one at a time. You don't, what I did here, this is for your development. It's not needed when you test this on Mirror, because what happens is when you test on Mirror, the main part, the whole main function is ignored, and that's what this helps us out with. So when I test on Mirror, I don't call main, and I send it 7 cards, and then we see if it matches up. Okay, so hopefully that gives you an idea to start this. You got to run through, you got to create all those. I found that it was helpful because there is this kind of action all the time. I create a flush, and then there's a straight. Oh, and then a straight flush. Whoa, that's really a combination of straights and flushes. So you might be able to combine these together. So there's a whole variety of ways that you can attack this problem, and I found that it was helpful to actually make a function that combines suits and things like that. So I did have some helper functions there. So hopefully this gives you an idea to start with. Good luck.